first step then in developing this parallelogram into a square of equal area is to inscribe this parallelogram into a rectangle. So we're just going to draw the outer frame that the parallelogram would fit in, and then we're going to plot our points. So we start by drawing the baseline of this rectangle at a length of 85. That's that line, and we are going to measure off the points 15, then 50, then 20, as shown in the diagram. Now that we have our baseline, we are going to draw the length or the height of the rectangle that this parallelogram would fit in. So it goes up 82, so we're just going to draw that up. Now, and then we're going to split that into, we're going to mark off our heights then. So there's 30, 40, and then our top point is of length 52. Now, so there we have our rectangle that our parallelogram will fit in. So now we can start plotting some points. So we know that from the diagram, the length 50 here, that is our baseline for our parallelogram. We're going to just label these points A and B. Next, we come over 20 and up 40 to this point, and we're going to label that point C. And then we're going to come over here and we're going to come out 15 and up 30. This is our 30 line. We're going to come out to this point and we're going to draw that in there, and that is going to be our point D. Now, so now that we have those points plotted, then we can think how we're going to go about plotting point E. So point E is on this line at a height of 52 from the 30 line, as we know. So we are going to, because we know that the point is on this line, but we don't have any of the dimensions or angles that we can go off at, all we know is that the internal angle of point E will be 75. We're going to incorporate the theorem that the angle subtended by an arc at the center is twice the angle subtended at the circumference. So this little theorem here that I have drawn out shows that this line here, or this arc here, that's going to be our point E. So we're going to just label that 75 degrees. And then we know then that this angle will be double that, so that's going to be 150 degrees. So from that then, we know that if we join point C and D, use that as our baseline, we know that there's 180 degrees. Excuse me. We know that there's that the angles in a triangle all add up to 180 degrees. So if we label this just to make it more clear, this is our point D and this is our point C. So we see now the relationship between these lines here. So if we take 180 degrees, I'll just do it up here, 180 degrees minus the 150 degrees, we know that that results in 30 degrees. So the reason we did that there is because these three angles all add up to 180 degrees, minus the 150 to find out what these two angles are. So we're left with 30, and then if we divide that by 2, we know that that is 15 degrees. So the angle from D to E, or the angle from D to the center point here, is 15 degrees. Similarly, from C to the center point, that is also 15 degrees. So we can go then with our protractor and we can come out 15 degrees from there and join that up. So then that we know that where these two lines meet will be the center point for a circle that we can swing. Now this point here, that is the center point for the circle that we can swing. The circle will cut through point D and C and also this top line here. And where that circle cuts this line here, that will then be our point E. So if we get our compass there, and just make sure that these 2 points are the same distance away. See, that's a little bit off. So now we can swing that arc. And now we know that that correlates exactly here. So where the circle has cut this line, we mark it and we label it point E. And if we want to be absolutely certain that that is at 75 degrees, we can simply measure it. So I'll draw that in now. And I can measure this angle with my protractor. Oh, sorry, no, that's not. Now we can see that that'll be just a little bit off. That's just a drawing error. But the theory is the same. So that is how we would then find that interior angle. So now that we have our pentagon drawn, we can go about transferring this pentagon into a square of equal area. So the first step then in doing that is to actually transfer this pentagon into a triangle of equal area. So what I did there is I extended my line AB, and that's that line here that you can see. And I joined point E to point B and point A to point E also. So now what we're going to do is we're going to use the sliding technique for our set squares, just to get parallel line from E to B, and we're going to draw a parallel line through point C. Then this, where that line cuts through the extended AB line, that is now one of the points on our triangle. And we can use the same technique then from point E to A, make sure they're lined up correctly, and just slide that on over until it cuts through point D. Now, and then we draw that line. And where that line cuts through the extended AB line, that gives us our second point on the triangle. And the other point then is point E. So with my pen then, I'm just going to mark in our triangle. Now, oh, sorry, no, my pen didn't work there. Now, so by joining these 3 points now, this gives us a triangle with the same area as the pentagon. So the next step then is to transfer this triangle that has the same area as the pentagon into a rectangle. So to do that then, we drop down line E, which appears to have already been drawn for us. Now we drop down point E, and we've not to confuse point A, the line from point A to E, as being perpendicular to the baseline. It's not. It's just a little bit. It's just a couple of millimeters off there now. So make sure we take the right line. So we drop down that line then, and we bisect it. So we should know how to bisect a line by now. An arc either side of the line from each point, and then where those arcs intersect each other, if we join them points, we get the perpendicular bisector of that line. Now, so you can just draw that in a little bit light, maybe a bit lighter than I've drawn it there, but for the purpose of the video I just did it a little bit heavier. So that is the center point there of that line. And we don't even need the center point, we just need the perpendicular bisector of that line. So if we extend the line through the center point, that will actually be the top of the line of our triangle, or of our rectangle, excuse me. So the next step then is to bring up the points of the triangle until it meets that line. I might just do it in pen. So we extend these lines up to that line, and from here also up to the perpendicular bisector. And if we join these points here, this rectangle now is a rectangle with the same area as this triangle in red here. So now that was our final step now in preparing ourselves to transfer the area into a square of equal area. So now to use the geometric mean excuse me method, we can transfer this rectangle into a square. So we do this by extending this line. You just extend it a little bit there, and we extend the line up here as well, just at a random distance, just make sure it's good and long. And we get our compass then, and with the needle of the compass at the corner of the rectangle and the length of the compass as the height of the rectangle, excuse me, I can swing an arc there until it cuts that line. And now where that point cuts that line, that point to this point is now all one line. So we can then bisect that line. So by bisecting this line now, we are giving ourselves the center point of that line. Nice and light. This point here is now the center point. I'm just going to label that P. So now with the needle of our compass on the center point of that line, we can draw an arc from that point there. Make sure it's correct, yep. So now we can draw a semicircle. And as we should know by now, the line from the center point vertically up to the semicircle, that point there is now our arithmetic mean, as we should know by now. Just going to label that AM. And from this point, from the corner of our rectangle, if we go vertically from that point up to the semicircle, not only is that line our geometric mean, but it is also one of the sides of our square. So now that we have that now, we can get our compass again, and with the needle of the compass in the corner of the rectangle and the height of the geometric mean, so a little bit more, we can cut that down. Now that is the next point of our square. So now we have two sides. So we can just swing that line there so that we know now if we extend this line up to that curve, and if we bring that line across, they should match up perfectly, and they absolutely do. So now what we are left with here, this square labeled 1, 2, 3, 4, that square is of equal area to the rectangle, which is of equal area to the triangle, which is of equal area to the pentagon that we originally started out with, the ABCDE pentagon. So this square and this pentagon now have the same area.